Hello, and welcome to AWS Innovate 2018 Virtual Conference. My name is Will Better, and I'm a Senior Technical Account Manager based out of Wellington, New Zealand. Today, I'll be talking to you about how to create and build an anomaly detection model using Amazon SageMaker. In this session, we're going to cover a few things. First, why do we care about anomalies and anomaly detection, and why is it critical to businesses? And then, I'll cover some ways to detect anomalies, and we'll give you a peek at how the algorithm works. Finally, I'll walk you through a demo on creating an anomaly detection model using one of the Amazon's machine learning services called Amazon SageMaker. We live in a world where people, homes, businesses, and cities are all covered with sensors and full of data. We use devices like smartwatches and fitness wristbands that can record your heart rate and the steps you walk. There are also sensors in cities where you can monitor real-time traffic data as well as weather conditions. So we're not only living in a world of big data, we're living in a world where the data is getting bigger by the seconds. And it's quite impossible for humans to manually try to look at all the data streams coming from all these different devices and sensors, simply because the scale is massively big. We also have all these streams of data continuously generated, and the value of the data can diminish over time. So it's in our best interest to try to gather some insights and meaningful values out of the data as soon as we can. One of the insights and values that we can get out of the real-time data is identify anomalies. For example, medical sensors can know when a patient is feeling unwell. Smartwatches with real-time heart rate data can predict when a person might have a heart problem. We can even try to uncover a bottleneck in your IT infrastructure by finding anomalies in the data traffic between servers. Therefore, we need to find automated mechanisms or algorithms to watch this data and to determine if something is anomalous. So, what is an anomaly? An anomaly is an observation that diverges from otherwise well-structured data. It's an exception or outlier or anything unusual that deviates from the normal pattern of the data flow. Real-time anomaly detection is really important because the faster we can know about it, the quicker we can take corrective actions and try to fix the problem. So, what does an anomaly look like? Let's assume that we have two-dimensional visualization for temperature sensor data over a certain period of time, where the temperature is high at the beginning of the day and it goes down by the end of the day. As you can see in the graph, there are two different anomalous data points that diverge from the pattern. They manifest as unexpected spikes in a time series or breaks in predictable patterns. In other words, an anomaly is simply an exception or outlier or anything unusual in the data. Detecting those outliers is one of the most important problems across different industries and technologies. One way to do this is to simply use thresholds. For example, we can have a predetermined limits that are set to notify for anything abnormal, or for when the data points exceed that threshold. However, thresholds can have quite a few weaknesses. First, it's hard to know what that threshold should be. And when you set it, there are tons of false alarms until you get the right value. Second, thresholds don't make predictions on whether or not the problem will happen. It usually finds the problem after it occurs. Third, it also doesn't adapt to the new states and the dynamic nature of the data. So there must be a smarter way to do this, a way that can leverage machine learning to understand and learn more about the data and how to detect anomalies. And that's what we're going to try to achieve using Amazon SageMaker. Amazon SageMaker is an end-to-end machine learning platform and a fully managed service that makes it easy for data scientists and developers to quickly build and execute machine learning pipelines into production. It takes away the heavy lifting of machine learning so you can build and deploy your models much quicker and much easier. It also removes all the barriers that typically slow down developers who want to use machine learning. SageMaker supports all frameworks, and it has a bunch of built-in high-performance machine learning algorithms that can be used out of the box for a variety of problems. Algorithms like image classification that classify and recognize different images, or sequence-to-sequence that can be used for machine translation and text summary, or factorization machine that can be used in click predictions and item recommendations. But in this talk, we'll focus on random cut forest algorithm, which we'll be using to create an anomaly detection model. Now, let me show you a high-level overview on how the algorithm works. Random cut forest is an unsupervised algorithm for detecting anomalies in a numeric, high-dimensional data streams and data points. For simplicity, let's assume that we have a few data points in a two-dimensional space. We can clearly see the outlier data points in orange. The algorithm associates an anomaly score with each data point in your dataset, and the score is based on how far it is from the circle. Low score values indicates that the data points is considered normal. High values indicates the presence of an anomaly in the data. The definition of low and high depends on the application itself, but common practices suggest that the score beyond 3 standard deviations from the mean score are considered anomalous. I understand that there might be some curious people who wants to know how the algorithm works. So let's zoom up on that to understand how it calculates the score. The main idea behind the RCF algorithm, or random cut forest algorithm, is to create a forest of trees. Again, for simplicity, let's assume that we have two-dimensional data points in a space with the majority of data lies in clusters, except for one anomalous data point in orange. First, we try to compute a bounding box of data, and the way we do that is by trying to find the minimum and maximum values of each dimension. Second, we select one of the dimensions and we do a cut randomly anywhere it ranges through that dimension. In our example here, we did the random cut through dimension X. And then we compute another bounding box for the data points on the right-hand side, and the same for the data points on the left-hand side. And we do the cut again in the new bounding boxes. If there's a point that is an outlier, there's a very high probability that this point will be closer to the root of the tree, and that's because it will be cut and become isolated early in the process. The closer the point to the root, the higher the score gets. And we keep doing that until every point in the tree is completely isolated. For more details about the random cut algorithm, please refer to the algorithm research paper. Now, enough of the algorithm. Let's get to the demo and let me show you how you can build this using Amazon SageMaker. In this demo, we're going to use the SageMaker random cut forest algorithm to train a model on a public dataset. We're going to use the Numenta Anomaly Benchmark Device Temperature dataset, which records temperature sensor data from an internal component of a large industrial machine. We'll then use this model to predict anomalous events by emitting an anomaly score for each data point. The main goals for that demo are, first, to learn how to obtain, transform, and store data for use in Amazon SageMaker. Second, how to create an AWS SageMaker Training Job on dataset to produce an RCF model. And lastly, use the RCF model, or random cut forest model, to perform inference with the Amazon SageMaker endpoint. In this example, I'll show you how to create a training job using the console GUI. So let's navigate to the SageMaker console by searching for SageMaker. And as you can see, there's 4 different components for SageMaker: notebook instances, training jobs, model artifacts, and inference endpoints. So let's go to the training jobs. And let's go ahead and create our training job. First, we need to give it a name. So we're going to give it a name, something like random cut forest job. And then we need to select the IAM role, which is simply the permissions that the job needs to access other AWS services like S3 buckets. So I'll leave it to the default one. And then we need to select the algorithm. And in this case, it's random cut forest. And the input mode, we've got two different input modes. We've got the file and the pipe one. In the file one, we take a full copy of the training dataset and place it inside the training instance. And in the pipe mode, the training job streams data directly from Amazon S3. And it's recommended if you have a large dataset. In this case, we're going to select file mode because the dataset is small. Now we need to specify the configuration for the training instance. So we've got the compute optimized nodes, and I'm going to select the C5X large for that reason. And I'm going to leave it to the default. Now, if you want to encrypt the data inside the training instance, you can select the encryption key from here. And this is the maximum runtime for the job. Also, if you want to place the training instance inside your VPC or private VPC, then you can do that by selecting the VPC from the drop-down menu. And then we need to specify the hyperparameters. So we have feature dimensions. In this case, I have just one feature dimension in my dataset. And then the number of samples per tree, I'm going to leave it to the default, which is 256. Then the number of trees in a forest, I'm going to leave it to the default. And the evaluation metrics, since I'm not using it, so I'll just leave it to the default. Now it's time to specify our training dataset and configure the channel. So the type of the dataset is going to be record IO formats, protobuf. So let's take a copy of the suggested list or supported list. And the dataset is not compressed, so I'm going to leave it to none. And the data type is S3 prefix. And then the S3 distribution type, the random cut forest only supports sharded by S3 key for the training channel. Now we need to specify the S3 location. So I'm going to go switch to the S3 console. And just to show you how, where the training set is placed, this is a training set, and this is a training file, the record IO format. Let's go ahead and take a copy for the path, and then switch back, place it here, and fix the S3 location path. This looks perfect. Now it is done. And the final step here, we need to specify the S3 output location, which is where the model is going to generate the model artifacts. So I'm going to specify the output folder and create the training job. And you can see in the console that the training job started here. So let's click on it. And you can see the status, so the training job is in progress. And you can see other details for the job, like the job name, the IAM role, and so on. Let's scroll down. You can see the algorithm details and the instance configuration, the maximum runtime, the input data configuration for the training, and the output data configuration, and the hyperparameters. I'm going to fast forward a little bit until the training job is finished, and I'm going to come back after the job is finished. Thank you. Now that the training job is finished, I'm going to scroll up to confirm, and as you can see, the status is completed. Now we also need to confirm that the model artifacts has been generated. So let's switch to the output path. So I'm going to switch to the S3 console, and this is the output location that was specified for the training job, and this is a training job name, and then the output folder. And as you can see, the model is generated in a compressed format and ready to be consumed. Let's go ahead and start deploying the model. Model deployment is a three-step process. First, we create the model in SageMaker. Then we create an endpoint configuration for an HTTPS endpoint. Then we create an HTTPS endpoint to make the predictions. So let's go ahead and create the model. Now we need to give it a name, something like random cut forest model. And then we're going to select the IM execution role, which is the same role that we selected for the training job. And as you can see, the primary container information is already populated from the training job. And this is the name of the container, and this is the output location for the model artifacts that's going to be consumed. Now we create the model, and instantly the model is created. And as you can see, the model information is here. Now let's go ahead and create the endpoint configuration. Let's give it a name, something like RCF endpoint configuration. And you can see that the model is already selected. And this is the instance type that's going to host the model. So let's go ahead and try to change it to a compute optimized instance. I'm going to use C5 large instance. I'm going to leave the rest as the default. Now let's go ahead and create the endpoint configuration, and instantly it is also created. Let's open it. So if we already have an endpoint and we're just releasing a new version of the model, you can apply the model to an existing endpoint by clicking here. But since we don't have an existing endpoint, I'm going to go ahead and create a new one. So create endpoints. Let's go ahead and give it a name, something like RCF endpoint. And we're going to select the endpoint configuration that we just created, which is RCF endpoint configuration, or EC. And let's give it a tag so it can be easy to find it later on. So the key is going to be name, the value will be temperature, anomaly detection. And don't forget to select the endpoint configuration by clicking here. And then click on create endpoint. And as you can see, the status is creating. And that's going to take a few minutes in order to finish. And then you're going to have an endpoint that you can use for predictions. Let's switch back to the SageMaker dashboard. And as you can see in the bottom section, we have two in-service notebook instances. So let's click here. I'll be using the demo notebook for the demo today, and the instance type is just T2 medium. And that's because the training job doesn't run inside the notebook. Let's open it, and that will open the SageMaker hosted Jupyter Notebook. So Jupyter Notebook is an open source interactive web application IDE that allows you to create and share live code and visualize your data. So this is a file for the demo. And that will open the Jupyter Notebook itself. So in the first block of code, I'm just importing some libraries like Boto3 and SageMaker. And then I'm setting my bucket name. And this is a bucket that will host my training data. So I'm going to upload my training data to this bucket. And then the rest of the code is just checking if the bucket exists. Let's go ahead and run it. And as you can see, the output of that block of code is showing below. Now the next step is to have a look at the dataset in order to understand it a little bit more. As I mentioned, I'll be using the Momenta Anomaly benchmark dataset that equals the temperature sensor data for the machines. Let's open the dataset file. And as you can see, we've got two different fields, the timestamp and the value, and each line of the dataset file represents 15 minutes of temperature readings. Let's switch back to the code. And in the next block of code, I'm downloading the dataset in a CSV format, then loading the dataset in a data frame object. So let's go ahead and try to run this. And then in order to make sure that the data frame has been loaded successfully, I'm going to try to list the first 5 values out of the data frame. And as you can see, it's been listed successfully. Humans are great in visualization. Let's visualize the data in a 2-dimensional histogram. And in order to do this, I'm using a library called Bouquet. Bouquet is a great open source and interactive visualization library. Let's go ahead and try to run this code, and that will eventually print the histogram in the notebook. And as you can see, our human eye can detect two different anomalies in the dataset without even running the machine learning algorithm yet. So you can also try to zoom in that section of the anomaly in order to try to get a little bit more insights around this time period. So let's try to zoom in. And as you hover over the data points, you can see the temperature alongside with the dates and time of that temperature. Now let's move to the next block of code. And this is a function that's going to try to convert the data set in order to make it ready to be consumed by the training job. And I'm trying to convert it from the data frame format into a record IO format, which is the format that we prefer for training jobs. So let's run it. Now, after the conversion happened, I uploaded the dataset to the bucket we specified at the beginning of this notebook. Now, we're going to try to write the configuration for the training job. First, we specify the container that we're going to use for the training, and I'm simply using the container provided by AWS for this random cut forest algorithm. And then I'm creating a construct called estimator. The estimator construct simply an object that contains all the details of the training job, including the instance type that we're going to use and the execution role and the container. Then I'm setting the hyperparameters as discussed before. So this is a number of samples per tree, and the feature dimension is just one feature. I'm going to go ahead and run this block of code, and the training starts by calling the fit function and passing the S3 training input object as an argument, which is simply the details of the train channel. Now the training process has started, and that process will take a few minutes to complete. After the training is finished, this line will print the training job name. So let's go ahead and run it. Now the next step is to create an inference endpoint that can be used for predictions. So I'm simply calling the deploy function, and I'm passing two different arguments. So I'm passing the initial instance count, which is a number of instances that's going to be used for the endpoint, and the instance type that will be hosting the model. So let's go ahead and run this block. And I also want to print the deployment endpoint after it finishes. So let's run this one as well. Now the training process and the deployment will take a couple of minutes or a few minutes to finish. So I'm going to fast forward a little bit and come back after the model is created. Now I'm back after some time and the training job is finished. So let's scroll up. And as you can see, the training job logs has been printed out after that block. And if we scroll all the way down, you can see that the job is complete and the amount of billable seconds, which means you only pay for 127 seconds of training. Now let's try to take a copy of the training job name because we're going to use it later on, just to have a look at the training job. And then scroll down to have a look at the inference code or the deployment code. And it looks like the deployment is also finished. Now let's switch back to the Amazon SageMaker console. And let's go to the training jobs and search for that training job. And let's click on that job. And as you can see, the training duration is 2 minutes and the job is completed. Let's also have a look at the endpoint. So you can see, as you can see here, the endpoint is created, it's in service, and it's ready to be used for predictions. Now, let's try to prepare the data for predictions. So I'm just serializing the data in this block of code and converting the data later on from CSV format into NumPy array. And then I'm sending the NumPy array to the endpoint in order to make the predictions. So I'm just calling the predict function and I'm passing the NumPy array that I converted from the CSV format. Let's run this code. And the prediction results has been stored in this variable called results. Now the next step is to compute the anomaly score for the training dataset and to visualize it in a graph. So the next block of code is just creating some functions to process the input dataset and to create the visualization graph. So I'm going to go ahead and run those code. And this prediction function is just going to print the anomaly scores in a graph alongside with the data. Now you can see that there's one high temperature anomaly and then a series of anomalies that has been predicted early on in the process. As the temperature goes down, the data points sounds and looks more anomalous. That's why the anomaly score is increasing as you go down. You can also see that there are some other anomalies that has been detected in the black dots, which is here and here. But since I already know the dataset very well, I can know that the first anomaly on the left-hand side was a planned shutdown for the device. The second anomaly was a subtle anomaly that led to the failure that comes next, which is that one, and that one that led to the next anomaly, which is a catastrophic system failure, which is that one over there. Now let's try to pass on a complete new dataset to our prediction function, and let's see how it's going to identify the anomalies in that new dataset. So that file, 10 predictions.csv, is a complete new dataset, and after I ran that code, as you can see, the black circles are more anomalous data points, which are also a data point or anomaly that happened when the system was shutting down or rebooting. And this is the end of my demo. Since I'm not going to use the data points anymore, I'm going to go ahead and delete it, and this code will delete the endpoint. Thanks for listening. So, detecting anomalies and finding unusual behaviors or patterns is very critical to any business or industry. Whether you work in health, IT and technology, retail, or any other industry, it's crucial to leverage your data and to extract insights and drive business outcomes. You can get started now with cost-effective solutions like Amazon SageMaker to generate outcomes, then deliver results. To gain more confidence and hands-on experience with AWS, access the digital training built and delivered by AWS experts. AWS has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. To learn more about how APM partners can help you, visit the AWS partner booth at our showcase. Finally, I would like to thank you for attending today and sticking it out until the very end of the presentation. Thank you.